In this section, we're going to be discussing rigid motions, which is a combination of the three types of transformations that we have already learned about: translations, rotations, and reflections. So first we need to know what it means to be congruent. Congruent is all figures or shapes that are identical, meaning the size, the angles, the side lengths, everything about it is identical. The symbol for congruence is right there, the equal sign with a little squiggly on top of it. Two congruent shapes, when you translate one to the other, it will be called rigid motions, is what we want to call it. Because when you do a sequence of translations and the two shapes are congruent, that means we did rigid motion. So let's get to some examples here. So given that triangle ABC is congruent to triangle A prime, B prime, C prime, we want to describe the sequence of rigid motions that maps the original to its image. So here we are given multiple choice. And we need to see which one of these multiple choice answers is the correct one. So when we see multiple choice answers like this, and it gives us a bunch of steps to do, we need to pick one point, and one point only, because we know that the two shapes are congruent. So if we pick point A, it's got to map to point A prime. Those are the first letters in both the triangles listed. So A has to go to A prime. So you can pick B or you can pick C. It does not matter which one, but you can map it to its image. So if I pick A and I follow this first one, it says a translation of 5 units to the left. Well, if I go 5 units to the left, I'm off the graph, and then 6 units up, and then I am done. I am not on A prime. So this is not going to be my answer. So next, it says to reflect over the x-axis. So here's a reflection of A over the x-axis, and then translated 5 units to the right. And there would be 5 units to the right. That is not on A prime, so that is also not the correct answer. Let's try the third one. A translation down 5 units, translation of 5 units to the right. So right here would be 5 units to the right. And then 6 units down. And as you can see, I end up on A prime. So this is going to be the correct answer. My rigid motion is a translation of 5 units to the right and 6 units down. So I know that the last one is not going to be the answer, but let's go over things anyway. It's a rotation of 180 degrees. So if I'm going to make 180 degrees, this is 4, this is 5. I go 4, down 5. And then a translation of 2 more units down, that would put me right here, which is nowhere near A prime, proving even further that it is the translation 5 to the right and 6 down. So next, we need to pick just a point. So I'll pick point D in our original, and I'll follow the steps in all the options. So translate a translation of 4 units to the left, and then up 2 units, and look at that, I end up on D prime. Since I ended up on D prime, that is my answer. And in multiple choice, once you find the answer, that is going to be the same for every single coordinate. As you can see, we go 4 units to the left. Whoop, I went a little too far, but 2 up. And you end up on E prime. And from F, 4 units to the left, up 2 on F prime. As you can see, they're all the same for all the coordinates, proving that that is the correct answer. So the first two dealt with just translations. Again, there's other transformations we've gone over. So I'm going to pick just point A here. And my first option says a rotation of 270 degrees. So let me connect A to the origin. If I go 270 degrees, I end up right there. And then reflect over the y-axis. Well, if I reflect this over the y-axis, I end up right here, which is not on A prime. So this is not going to be the correct option. For my second one, it says a reflection over the y-axis. So if I reflect A over the y-axis, I'm right there. And a translation of down 6 units, 1, 2, 3. I end up on B prime. I need to end up on A prime. So this one is also not the correct answer. Next one, a translation of 7 units to the left. So here's 7 units to the left. And then down 6 units. And I end up on C prime. Again, A maps to A prime, so this is not the right answer. So it's got to be the last one. So let's do it to make sure. It's a reflection over the x-axis. So here's a reflection over the x-axis. And then another reflection over the y-axis. And I end up on A prime. So if I were to do all of them, as you can see, the reflection over the y would end up being the correct answer in this case. Now let's pick one point here. So let's pick point M. M maps to M prime. So a translation of 4 units to the right. So there's where M, which is on top of J, but I'm not done yet. It says then a rotation around the point 2, -2. Here's 2, -2. It does not say how much, so let's write in 90 degrees. If I were to rotate or turn, if it would be just like turning it around the middle of the square there. M would then come over here to M prime, and it does, in fact, translate to the correct one. So that is your answer there. Now, we usually rotate around the origin. We don't typically rotate around points like this option had. But in this case, so you'll only see rotating around the origin. So a reflection followed by another reflection is the exact same thing as a rotation. So over here on the left, you can see a reflection over the y-axis and then a reflection over the x-axis. That is the same thing as a 180-degree rotation around the origin. So both of those can be used as translations, but it's just quicker to go to the rotation than a reflection. Just some things, nice things to know. Now, what effects does this have on side lengths? So because AB is listed first, see how it's in green there, and then EF is listed first, which is also in green. Since both of these shapes are congruent, that means their side lengths, their corresponding side lengths, are the exact same measure. So since both shapes are congruent, then the corresponding side line segments are equal in measure. They're the same exact size. You can tell which sides are congruent by the order in which they are labeled. Remember, order is going to matter in all of these. Same thing here with the angles. Since both shapes are congruent, then the corresponding angles are equal in measure. You can tell which angles are congruent by the order in which they are labeled. So if we go back here to see how it was labeled, angle A is the same measurement as angle E because A was listed first, and then in the image, E is listed first. And you can see how A is shaded in blue, and so is angle E in the picture. Also with parallel lines, if line segment AB is parallel to line segment DC, then those lines will never intersect. And if they are parallel in the original shape, then they will be parallel in the image as well. This all goes with being congruent. So again, if two shapes are congruent, everything about them is the same. So is triangle JAR congruent to triangle LID? Well, we can do that by seeing if the side lengths are the same. And back when we did the Pythagorean theorem, we can make these triangles right here. To go from J to A, I have a 2 by 4 triangle. Now you could do the Pythagorean theorem to find the actual side length, but since J and A are the first two listed, L and I should be the exact same right triangle. And if you look, that is also a 2 by 4 triangle. So far, those two side lengths are the same. Now, if I go A to R, I have a 2 by 3 triangle. So then if I do I to D, I also have a 2 by 3 triangle. So if I did the Pythagorean theorem, these line segments would match up to be congruent. I'm going to mark these as congruent as well. And then lastly, J to R is a 4 by 1 triangle. So if I do L to D, that is also a 4 by 1 triangle. Since those are the exact same triangles made, when we do the Pythagorean theorem, we get the exact same measurement. So yes, the two triangles are congruent because corresponding sides are equal in measure. So we're using what we've learned in the Pythagorean theorem earlier in the third quarter to come up with which triangles are congruent. So here, which two triangles are congruent? Well, the one that sticks out to me is triangle JKL here with that big 90-degree angle. I do not see any other ones with a strong 90-degree angle like that, so I'm just going to cross that one out right away. Now again, I'm going to start to use my Pythagorean theorem. I'm going to make a triangle from A to B. So typically these go in order, so triangle ABC. So triangle A to B right there is a 2 by 1 triangle. Let's look at D to E. That's also a 2 by 1 triangle. Triangle G to H is a 2 by 1 triangle. So far, it looks like all three of these triangles are the same. So let's go B to C. I have a 3 by 1. And then if I go E to F here, that is just a straight line. I do not create a triangle. That's 3 units long. So I know that ABC and DEF now are not congruent because to go from B to C, I had to create a triangle to find the length. To go from E to F, I did not create a triangle to find the length. Therefore, those two are not congruent. So let's go from H to I here, and I create a 3 by 1 triangle, meaning this one is not congruent. So the two triangles that are congruent are triangle ABC is congruent to triangle GHI because corresponding side lengths are equal in measure.